Good morning, algebra students. Today we're going to be working with, to begin, I apologize that I'm not able to be here today. I think I mentioned to you yesterday my grandma isn't feeling very well, and anyways, I had to bring her to the doctor, and so that's where I am today. But this is the second best you get of me is a recorded voice of me. So. Today we're moving on to 11.2, and that's operations with radical expressions. And what I hope that you will be able to say that you can do is that you can add and subtract radical expressions, and that you can multiply radical expressions. Okay, so our first example of problems that we have are expressions with like radicans. When we say radicans, it's the plural of radicals, but the radical, but in this case, these are our radicans. It's the number that is that we're taking the square root of. And in this case, we've got the square root of 5, the square root of 5, the square root of 5. So I want to step back for just a second. If we took 2 times 5 and 3 plus 3 times 5, we know that 2 times 5 is 10. And 3 times 5 is 15, and together those are 25, okay? We also could do this another way. We could do, since we have 2 times 5 and 3 times 5, that's also, we could do 2 plus the 3, and that's 5, and do 5 times 5, and that equals 25, okay? So whatever, if we're multiplying by the same number, then we can simply add those numbers that we're multiplying by together. And the same holds true when we're adding like radicans, okay? So since we have the square root of 5, the square root of 5, the square root of 5, all we're going to do is 6 plus 2 minus 5. Okay, 6 plus 2 is 8. 8 minus 5 is 3. So when we expressions with like radicans, we can just it's the same thing as combining like terms. We've got 3 radical 5. And that's our answer. So here we've got another problem, 7 radical 13x minus 14 radical 13x plus 2 radical 13x. In this case, if you want to, go ahead and press pause and solve it and see if you get the same answer that I do. Okay. So here I see I've got like radicans. They're all radical 13x. I don't know what x is, but I can still simplify this by, again, combining like terms. So I'm going to take the 7, the negative 14, and the positive 2, and I'm going to combine those. So I've got 7 minus 14 plus 2. So that's, what's that, 7? 7 plus 2 is 9, and 9 minus 14 equals negative 5. So I know that I've got negative 5 radical 13x. Simple as that. So I've decided to show you one more problem with that involves like radicans. However, you'll see how this one's just a little different. If you're at your desk and you want to go ahead and try to solve this, take a moment and press pause if you. And then we'll come back and do it together. Okay, so hopefully you saw that these radical 2, radical 11, radical 11, radical 2, those are simplified. You can't reduce those anymore. So, but we can't combine 7 radical 2 with 8 radical 11. We just can't do that. What we can do is we can combine 7 radical 2 with negative 6 radical 2. And we can combine, let's do this in a different color, 8 radical 11 with negative 4 radical 11. And we know 8 minus 4 in this case is 4, so that's 4 radical 11. And here, 7 radical 2 minus 6 radical 2 is plus, that's going to be a positive radical 2, positive 1 radical 2, but you just write it as radical 2. And that is your answer. You can obviously have those. You could write this like this also. It's the same thing. Excellent. Okay, I've gone ahead here and moved on to the next page, and this is now we're going to be learning how to deal with expressions with unlike radicals. First off, you can't just, again, as we did on the last problem, you can't just add across here. You can't just say 6 plus 8 plus 2 and then add underneath there. If we're multiplying, you could, but adding you can't. You can't just say 6 plus 8 plus 2 and then add 27 plus 12 plus 75. Again, if we're multiplying, it's a whole different story, but adding we can. So what we do need to do before we're saying, okay, well that's the answer. You can't simplify it anymore. What you have to ask yourself is radical 27 in simplest form? Is radical 12 in simplest form? Is radical 75 in simplest form? And if it's not, then we need to go ahead and simplify it. And once we simplify it, then we can see if we have any like radicands. So right now what I want you to do is I want you to press pause and I want you to simplify radical 27 or 6 radical 27, 8 radical 12, and 2 radical 75. Remember that we use prime factorization in order to do this. So go ahead and press pause and simplify those. Okay, so hopefully what you did is you found prime factorization of 27. 27 is 9 times 3, and then that is 3 times 3. So we've got 6 times 3 times 3 times 3. We've got a pair there of 3's, and we can pull that up. That's 9. So the square root of 9 is 3, and 3 times 6 is 18. So that simplifies to 18 radical 3. Next I'll do 12 over here. So why don't I do this one in red? So I've got 12, and I'm going to do the prime factorization of this. So I've got 4 times 3. You could have started with 6 times 2, but it doesn't matter. And then I've got 2 times 2. So over here I've got 8 times 2 times 2 times 3. Okay? And again, I've got a pair. 2 times 2 is 4. The square root of 4 is 2. 2 times 8 is 16. And we're left with radical 3. Remember, that was a positive, so we're going to write that down here. It's 18 radical 3 plus 16 radical 3. Oops, that was a positive. And then let's do this one in green. We've got a positive 2 radical 75. So now I've got, let's do 75 on this side. We got 25 times 5, and then that's 5 times 5. So now I've got positive 2 times 5. Oops, I made a mistake, didn't I? I'm sorry. It's not 25 times 5, it's 25 times 3. 25 times 5 is 125. Sorry about that. So I've got, I like to do this in order. So I've got 2 times 2 radical 3 times radical 5 times radical 5, and then I've got my pair there. 5 times 5 is 25. Square root of 25 is 5. So 5 times 2 is 10, and we're left with a radical 3. Now, notice, I have like radicands, and I can simply add them together. What's that? 10 and 10 is 20, 8 and 6 is 14, so that's 34 radical 3, if I did my arithmetic correctly. Okay, so, and that's our answer. I just realized something as I was moving on. I had 18 and 16 is 34. I forgot to add the 10 in there. That is 44 radical 3, and that's your answer. Slacker teacher. Anyway, let's move on to our next problem here, and that is going to be, let's do radical 40 minus radical 10 plus radical 90. Okay? Now you can't just add those across, but what you do need to do is you need to find the simplest form of radical 40, negative radical 10, and radical 90. So go ahead and use prime factorization to get these three in simplest form. So if you haven't pressed pause, do so and do that. Anyway, I am going to continue on. And radical 40 simplifies to, I know, 4 times, oops, that one should probably be in red. You know, that simplifies to 4 times 10. I'm going to do this one a little different way. And then I know the square root of 4 is 2. And radical 10 is all I have left. Then I've got a negative radical 10. Well, I know, in this case, 10 is the only factors of that are 5 and 2. So I have no pairs. Radical 10 is simplified. Negative radical 10. Oops. I'm going to do that. Radical 10. And then finally, I've got 90. I'm going to do 90 over here. 90 is 9 times 10. Oh. Perfect square. So I've got a positive, in this case it's 9 times 10. Positive, that radical 9 is the same thing as 3 radical 10. So now I'm left with 2 radical 10, negative radical 10, and plus 3 radical 10. So I've got 3 plus 2 is 5, minus the 1 radical 10, that is 4 radical 10. And that's our answer in simplest form. Our final example for today's lesson is I want you to understand how to multiply radical expressions. So if you were asked to give the area of a rectangle that had the length of 4 radical 6 minus 2 radical 10, and the height of 5 radical 3 plus 7 radical 5, or length and width, I don't care which one you call it, we'll call this length, and this our width. If we had that, and you were asked to find the area, you could simply multiply this side times this side. You know how to multiply, but it's a little different with multiplying radical expressions. But you're going to see here in just a second that you've done this before. Okay, so I rewrite the problem like this in parentheses. So I've got 4 radical 6 and negative 2 radical 10. We're taking this expression and multiplying it by this. This is the same thing as FOIL. You're going to do first, outer, inner terms, and then your last terms. So there's 4 problems that you have to multiply here. Well, you can do 4 times 4 radical 6 times 5 radical 3. We can multiply the 4 times the 5, and that equals 20. And the radical 6 times the radical 3, that's radical 18. And then I've got 4 radical 6 times 7 radical 5. Well, 4 times 7 is 28. These are positives, plus 28. Radical 30. Okay, so just right here, this 4 times this 7. I guess I probably should have done this one in green, considering those were in green, but you guys understand. And then it was this 6 times this radical 5. Next, you're going to multiply. Sorry, that's not your bell. Next, you're going to multiply negative 2 radical 10 times 5 radical 3. That is negative 10 radical 30. And finally, negative 2 radical 10 times 3, negative 2 radical 10 times 7 radical 5. So negative 2 times 7 is negative 14. 10 times 5 is 50. That's radical 50. Your last thing you're going to need to do is combine like terms. And so you've got, well, almost last thing. You've got 20 radical 18. 28 minus 10 is 18, positive 18. So I combine these two. Radical 30 minus 14, radical 50. You're almost done. You're almost done here. So the last thing you have to do is make sure that these are all simplified. So in this case, 20 radical 18. You have to ask yourself, is radical 18 simplified? And I know 9 times 2 is not simplified because 9 is a perfect square. So the square root of 9 is 3. 20 times 3 is 60. 60 radical 2 plus, and I just know from, I've done this before, radical 30 is simplified. 18 radical 30. I got 6 times 5 and 3 times 2. So 3 times 2 times 5. There's no perfect squares there. And then 50. 50, I actually have 25 times 2. Well, the square root of 25 is 5. And 14 times 5 is 70. So we got negative 70 radical 2. Then we can combine this like term and this like term. I've got negative 10 radical 2 plus 18 radical 30. And that, ladies and gentlemen, is our answer. Okay, so I've got one more problem here for you. It's radical 2 plus 2 times radical 8 times the expression 3 radical 6 minus radical 5. I want you to go ahead and press pause and try to solve this one on your own. Okay, so at this time, I know I'm going to use, I'm going to multiply the expressions, and let's try to stick to the colors this time. We'll do radical 2 times 3 radical 6 and radical 2 times a negative radical 5. And we'll start by doing radical 2 times 3 radical 6, and that's, the 3 stays the same, but we multiply the stuff that's underneath the radical, that's radical 12. And then I've got radical 2 times a negative radical 5. That's a negative radical 10. And let's go ahead and blue. Let's do the other expressions. We have 2 radical 8 times 3 radical 6. That's 2 times 3 is 6. So that's plus 6 radical. 8 times 6 is 48. And then 2 radical 8 times a negative radical 5. That is negative, a positive times a negative is a negative, so it's negative 2 radical 40. I need to simplify all of these, and I know that this is 4 times 3, and 4 is a perfect square, so that's going to be 2, and that's not your bell again, 2 times 3 is 6, so that's 6 radical 3. Radical 10 is simplified. 48 is 24 times 2, which is 6 times 4. You know what? I'm going to write that a different way. I'm going to do, sorry. Yeah, we'll do it that way. I'm sorry. 24 times 2, 6 times 4. And I know that's 3 times 2. So I've got 2. I'm going to have to write it down here. 6 radical 3 minus radical 10. That is going to be the square root of 4 times 2 times 2 times 3. That's a perfect square, and 4 is also a perfect square. Square root of 4 is 2. That's 4 also, so 2 times 2 is 4. 4 radical 3. So that's positive 4 radical 3. So we have to take that 4 and multiply it times that, so it's 24 positive 24, radical 3. And finally, this is 20 times, or let's just do 5 times 4, or 10 times 4 on that. 10 times 4, square root of 4 is 2. 2 times 2 is 4. 4 radical 10, and that's a negative on this one. So, oh man, I got a little messy there, sorry. So I've got 6 radical 3 minus radical 10 plus 24 radical 3 minus 4 radical 10. So you just have to simplify all those. And then I've got, you can combine these like terms, that's 30 radical 3, negative 10, and negative 4 over 10, or negative 4 radical 10 is negative 5 radical 10. So that concludes today's lesson. Hopefully that gives you enough of tools to begin working on your homework. You can work with partners, you can use calculators, but let's not work with partners and talk until everyone's had a chance to watch the video and complete that. I have my book open, or you can ask the substitute teacher if you can see the answers, if there's an even number. Anyway, and if you have any questions with anything from 11.1 or 11.2, that's what we're going to be working on Thursday to review. And then on Monday, you're going to have a quiz. So just look at your assignment sheet real closely, and you'll see what needs to be done. Thank you very much, and that concludes the instructional part of our lesson.